Alright guys, welcome back. So having understood different properties of transition metals, in which we have four common characteristics of transition metals, and these properties include the following: formation of colored ions, and then they have variable oxidation state, and they have catalytic properties of activity, and then formation of complex ion, which is also known as coordinate or coordination compound. So in this chapter we are going to discuss a last willing considerably formation of complex ion, that is coordination compounds. So now I want you to understand these basic terms that I'm going to kindly explain. Have your jota ready. Number one, we have coordination compound. Coordination compound is a complex in which a metal atom is bonded to a number of ions or molecules. So now, this number of ions or molecules include the following. Most importantly, ligand. That is, any ion or molecule attached to a central metal atom by donating a lone pair of electrons. For example, this is copper, right? And then we have ammonia, NH3. So we know ammonia has lone pair of electrons, right? So this lone pair of electrons will be shared to this copper. So remember, whenever in a bond, that is, if a bond is to exist between two atoms, when two electrons are being shared to a single atom among the bonding atoms include, then such a bond is called a what? Coordinate bond. So that's why we are saying coordination compound, because it involves sharing of a lone pair of electrons from one atom to another. However, remember, in normal covalent bond, the atoms involved in the formation of a molecule or compound, each of them will share a single electron, right? So in coordinate bond is different. It's only one atom among the bonding atoms that will share two lone pairs of electrons. So that's why we say coordinate bonding. So as we see, this this ammonia, which shared these two lone pairs of electrons to copper, then it is called a ligand. As we see from the definition, that a ligand is any ion or molecule which is attached to a central metal atom. So in this case, copper is the central metal atom. I hope you understand this. So secondly, let us consider this structure. So this is a coordination compound. So coordination compound involve the following. We have the central atom. In this case is chromium, right? And then we have a ligand. This ligand is attached to the central metal atom directly. I hope you understand this. So that's why it is inside this bracket. It means it is attached to this central atom directly. And then we have counter ion. As we see, counter ion is outside the coordination sphere. This counter ion can be either positive ion or negative ion. We are going to explain. And then we also have a coordination number. Coordination number, as we see. So this coordination number is, let us define it simply as, is the number of lone pairs of electrons which is donated by a ligand to the central metal atom. I hope you understand this. This number is called coordination number. I hope you understand this. So now let us define some other terms before moving further. I hope you understand now. Before I continue, this bracket square you are seeing, this one and this one, they are called coordination sphere. I hope you understand this. They are called coordination sphere. So you can see this bracket, right? So they are called coordination sphere. This coordination sphere contains what is known as complex ion. So now let us go and explain complex ion, and then we move further. Alright, so now complex ions. We know that transition metals along with other elements, they form complex ion or coordination compound, right? However, the transition metals form complexes better than non-transition element. So what are the factors that enhance the tendency of transition elements to form complexes? Among them, we have vacant or partially filled low-line d orbital. We have explained this, right? And then small size, high charge, and then lastly, possession of a high crystal field stabilization energy. So this coordination compound we are talking about, they are made of two entities. Number one, complex ion, and then counter ion. So now, for complex ion, a complex ion consists of central metal ion that is bonded to a ligand. I hope you understand. And this ligand, we define it as electron pair donating species, right? Then the ligand and complex ion are bonded through what? Coordinate covalent bonds, as explained. So once the ligand and central metal ion are bonded together, then we say a complex ion is formed. Do you understand this? So for example, we have Fe, right? Cn6 negative 4. So this is a complex ion. So as we see in this complex ion, we have uh, ion Fe, which is the central ion, right? And then we have cyanide, Cn. This is the ligand. And then we have this square bracket, which is known as coordinating sphere. As you see, coordinating sphere. And then we have the charge, negative 4, right? We have the charge. So this is an example of a complex ion. Do you understand this? Then since we say it has two parts, then there is also what? A counter ion. So in this case, a counter ion are ions that are associated with complex ions. The counter ions have an equal but opposite charge of the complex ion. Do you understand this? So these ions bonded with complexes to form coordination compounds. They are outside the square bracket, that is, they are outside the coordination sphere. So recall that the coordination sphere is this, right? This bracket are the coordination sphere. So they maintain electrical neutrality in coordination sphere. For instance, this is what? A counter ion. And this counter ion has what? Has negative 4, right? As it is charged, it has negative 4. So the counter ion which will neutralize this negative 4 is what? Is potassium in this case. It has what? 4 positive charges, because we have 4 negative charges on the complex ion. Then the counter ion should have what? 4 positive charges, so that it will neutralize and make this coordinate compound a neutral. Do you understand this? So that's why we have a stable coordination compound which involves what? The counter ion and then the what? The complex ion. So that's why we say coordination compound involves two parts. Number one is what? Counter ion, and number two is complex ion. Thank you. Then next we are going to explain more in details. Now jot this down.